So right before we jump into our logic gates, I want to go ahead and set up some ground rules. They're very simple. The first rule is that our input domain will only be either a 1 or a 0, just because we're dealing with Boolean logic, which only takes in bits or binary. And our second rule is just a reminder of how gates work. We will provide a gate with an input or a set of inputs that will be processed by the gate, and then depending on that gate, we'll receive an output. These inputs, like I said, will either be a 1 or a 0. It will go through the gate. These inputs will go through the gate, which each gate has its own Boolean logic, which is what I'll go over in this video. And depending on that logic, we'll get different outputs. Cool? Righty, let's go ahead and get started with our first gate. Our first gate will be the NOT gate, or more commonly known as an inverter. The NOT gate is known as an inverter because it inverts your inputs. So in this case, the symbol for the NOT gate or the inverter will look like this, where you will have one input and one output. So for our first example, I'll go ahead and provide an input of 1 that will go through our gate, and our gate is an inverter, so it will invert that bit and we'll get an output of 0. Okay, simple enough. Now if we now give it an input of 0, 0 will go through our gate, and the gate will go ahead and flip that bit, and we'll get a result of 1. So it's pretty simple. A NOT gate just flips your input, whatever it may be. Our domain is only between 0 and 1, or 1 and 0, and yeah, depending on that input, it'll just go ahead and flip it. Cool? Awesome. Let's go ahead and start with the next gate that we'll go over. This one's slightly more complicated. It is an AND gate. An AND gate takes 2 inputs. So our previous NOT gate only took 1 input right here. But for our AND gate, this provides 2 inputs. 1, 2. So let's go ahead and start off with some examples. I'm going to go ahead and create a table off to the right side to keep track of our inputs and our outputs, because now that we have more inputs, it's a little harder to keep track of. Okay? Our first set of examples will be a AND gate with an input, 2 inputs. We'll start off with 0, 0. So I like to think of an AND gate of a series circuit. And for those of you who don't know about series circuits or parallel circuits or circuits in general, it's pretty easy to follow. This is our light bulb. Let's just assume that we provided battery power out here. So this is a light bulb, and we're trying to turn the light bulb on, okay? And these are 2 switches out here. So depending on these switches is what decides if this light bulb turns on or not, okay? So since we have an input of 0, that's our first switch, that means that our switch is open, okay? And then our second input is the second switch, and that one is also open because it is a 0. So looking at this picture, when electricity tries to run through this circuit, it won't be able to actually turn on this light bulb because electricity won't be able to flow because these switches are open. So it's kind of like a light switch at home. If your switch is open, then your light doesn't turn on, but as soon as you close that switch, then the light is able to turn on. So in this situation, you will have an output of 0. Okay? So I'm saying that this is our X input and I'm saying this is our Y input. This is how I will express it in our table. Oops, sorry, that's not supposed to be a 1. That's actually supposed to be a 0, right? Because the light doesn't turn on. So that'll be a 0. Alrighty. So 2 switches off means light is off. Oh man, that's huge. Okay. Alrighty, so let's go ahead and try with some different inputs. Let's say that instead that we provide the first input to be a 0 and the second input to be a 1. Okay? So in this scenario, our first switch is open because it's a 0. Yeah. Let me undo that. I don't know what that did. Okay. Our first switch is open because it's a 0. And our second switch is the 1, so that is closed. So kind of same scenario. The electricity won't be able to flow because our first gate is open. And it's kind of like having, if you have 2 switches that control the light, if one switch is open and electricity can't flow through here, then your light will not be able to turn on. So then you will get an output of 0. Okay, so our X is a 0, our Y is a 1, but our light bulb still does not turn on. Okay, next example will be a different set of inputs that will change our output. Now, if our first input is a 1, our second input is a 0, let's see what that looks like in our circuit. Our first switch is closed, and our second switch is open. So kind of same scenario as the last one. Electricity won't be able to flow and turn on this light bulb because although the first switch is closed, this second switch is open. So electricity will not be able to flow to turn on that light bulb. You will get an output of 0. So you have an X of 1, a Y of 0, light bulb still does not turn on. Okay? And this is our last example. And this example will have 2 inputs of the number 1. And the way this looks in our circuit is our first switch is 1, which is closed, and our second switch is also 1, which is closed. From looking at this diagram, now electricity will be able to flow through the entire circuit, and this light bulb will be able to turn on. So your output will be a 1. So 1, 1 gives you an output of 1. And this is how the AND gate works. Both of your inputs have to be true or 1 in order to get an output of 1 or true. Cool. The next gate that we're going to go ahead and go over will be our OR gate. Yeah. Why can I not draw? Will be the OR gate. And the OR gate looks like this. So just for reference, our NOT gate looks like this, and our AND gate looks like this. Okay? Actually, that OR gate is pretty terrible. Let me try that again. Do, 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 do. Oh my god, why can't I do an OR gate? Bleh, bleh. Okay, close enough. Okay, so same thing as the AND gate. It takes 2 inputs in order to get a single output. So I'm going to go ahead and also create a table off to the right hand side so we can keep track of this. And because we provide it with 2 inputs and we have a domain of 2 elements, we'll get a total of 4 outputs, just like last time. Okay. So we will provide an X, a Y, and receive an output. Bloop, bloop. Okay. I like to think of OR gates as a parallel circuit. So once again, we have our light bulb, and we have our first switch, and then we have our second switch. Doot. Cool. Let's go ahead and provide the gate with some inputs. Come on. Close enough. We'll go ahead and start with, I call them X and Y. We'll go ahead and start off with 0, 0 for our inputs. And just like the last example, 0 means an open switch. So once again, just pretend that we're providing a battery power or some type of voltage. And in this scenario, there is no way for current to flow through either of these and reach the bulb. So that means our bulb, let me add this small detail, will not, oh, what? That looks terrible. Wow. Okay, this bulb will not turn on, which means that our output will be 0. Okay, 0, 0 gives you an output of 0. Okay, so let's try some different inputs and see what outputs that gives us. Okay, for this example, we will give an input of a 0 and a 1. So this gate will be open since it's a 0, and the second, sorry, not gate, switch, and the second switch will be a 1, so that means it is closed. Now this is slightly different than a series circuit, because if one of them was open, then that means the entire circuit wouldn't work. But these two are independent from one another. So although the electricity would not be able to flow through here, it can definitely flow through here and reach the light bulb. Okay, and that means that our light bulb will now turn on. Doot. That means our light bulb will turn on. So given an input of a 0 and a 1, I should say 0 or 1, we will get an output of 1. So we have 0, 1 gives us an output of 1. Alrighty, and now if these were now reversed, let's make that bigger. A 0 or a 1. One, 0. Now this will be closed and this will be open. And just like that last example, although electricity would not be able to flow through this first loop here, it would definitely be able to flow through this one, and electricity would be able to reach that light bulb and turn it on, which means that we will get an output of 1. Okay? So we will have 1, 0 gives you an output of 1. Okay, and then for our last example, we will go ahead and use inputs 1 and 1. And what that means in our circuit is that the first switch is closed because it's a 1, and our second switch is closed, which is also a 1. In both of these scenarios, electricity would be able to flow through both of those. So either way, the light bulb would be able to receive electricity, and that means our light bulb will turn on, and we will have an output of 1. Alrighty? So this is how an OR gate works.